Okay, hi everybody. So the easiest way for me to do this for you, for this honors video, is to truly show you this on desmos. So what we're doing today is we're going to be graphing cosecant and secant functions. So all along I keep telling you that I can't show you your honors topics until we've totally been done with graphing sine and cosine functions. This is because you cannot graph the secant or the cosecant function without having graphed your cosine and sine functions beforehand. So if you are able to graph a cosine or a sine function, you are able to graph a secant or cosecant function. Basically, it's 1 to 2 extra steps added on to that graphing process, but the process itself is very self-explanatory. So when I'm doing some honors credit points, keep in mind that the actual sine or cosine function associated with this might be a little bit more difficult um, than that of what we're going to be doing in our regular ed or like on our normal test. Because keep in mind the only extra step for this cosecant and secant is learning where we crossing the x-axis, that creates an asymptote, and then making that associative secant or cosecant functions graph. So the extra process isn't incredibly difficult. It's the concept I want you to latch onto, and also being able to do maybe some higher caliber problems here. So let's take away our secant function and let's zoom out just a tiny bit. So we can see that this is our normal cosine function. Again, this is the parent function with no interruptions done to it. So there is no A, B, C, or D values here that aren't what they normally are. So a 1 or a 0. So this is what that one looks like with its period of 2 pi, right? Up here at 2 pi, period of 2 pi, 5 points, crosses the x-axis or its center point twice, and creating kind of this valley-like curve, starting at um, starting at x equals 0, and of course starting up as well, and making this curve. So let's add that secant function back in. And let's think about what's happening with the secant function in regards to our cosine function. So when you go to draw your cosine function, we have some asymptotes created here. So you can tell that we had these parabolas, right? Parabola and parabola. But what creates this parabola? Like, how do I have a parabola, another one, right? And let's zoom out more, and more, right? How are these going on forever and ever and ever? So whenever we have a function that for some odd reason discontinues, does not keep going in the direction that it once was, that effect, especially in this case, like just starts going up in the same direction every single time, that is because of an asymptote. Okay, so once we add an asymptotes here, that is what's creating this U or parabola-like shape. And notice it's on top and on bottom. So they basically alternate where it goes top, bottom, top, bottom, top, bottom. So it looks like there's a decent amount of space in between these, but that is because the function's actually on the lower half. And again, it looks like there's a decent amount of space between these, but that function is actually on the upper half. So what's the significance of where these asymptotes are at? Every time I see one, it's directly associated with a place where my cosine function is crossing my x-axis. So think about this and think straight up and down on this line of where this crosses my x-axis. I have an asymptote. Again, over here, asymptote. Here, asymptote, and so on, right? Every time I have an x-axis or an x intersection, I have an asymptote created. So how do we decide where these parabolas go, right? Parabola-like shapes. They go anytime you have a maximum or relative maximum or minimum point. So we have a lowest point of this function relative because it's not our lowest. So relative minimum here, it intersects at that point and you create your parabola. So this point should be 0, 1. It is a shared point where the parabola meets my cosine function, where this or the secant function meets my cosine function, secant meets my cosine function. And that truly is it for secant and cosecant. So if you create your cosine function first, you draw your asymptotes, and any place that your cosine or sine function crosses your x-axis, and then you decide where do my parabolas go, right, for the secant or cosecant function. They go wherever your maximums and minimums are. Okay, so it's truthfully just that easy. Let me show you a sine. I can type sine and cosecant. Again, keep in mind at this point, you're going to have to know sine and cosecant go together, cosine and secant go together. Okay, you'll have to know those two pieces of information. So now let's look at our sine function. Again, starting down, period of 2 pi, starting at our origin though, but we do cross the x-axis twice. And again, you're seeing these asymptotes here, and an asymptote, and an asymptote, and an asymptote every single time. You're also seeing these parabola-like functions meet your relative maximums and minimums of your sine function, and that is where they intersect and create this parabola-like shape. Okay, so again, zoom out, you're going to see tons and tons of these. They go on forever. So the main focus here is being able to graph your sine or cosine function, and thus going ahead and graphing your cosecant and secant function thereafter. Okay, so if you want additional help on this, it was easiest for me to be able to zoom in, zoom out, change a couple things on Desmos. So if you would like an actual graphing example, I did post a video of somebody that has a computer that I don't and is able to kind of make some notes on their laptop in a way that I cannot. So I did post a video of that if you need a little bit additional help or explanation for these cosecant or secant functions for graphing. Otherwise, I think that's about all you need to know to be able to do them.